we'll have info out there for everybody before we get to that point. Welcome to our first monthly hangout. This one is kind of off the schedule of what we're going to do for the rest of them. We're going to do them on the first Friday of every month, starting in January and going forward. Today's I'm going to talk about what's new in 2.1, some background of the project, and I'm going to go through a tutorial of troubleshooting port forwarding. It's one of the things that people do a lot, and there are a lot of potential things that can go wrong almost entirely outside of the firewall, but there's a lot of tools that are built into pfSense that'll let you troubleshoot those things, and we'll go through a lot of that stuff. First, a brief background of the project. It was founded in 2004, so we're coming up on 10 years now. The goal of the project as a whole is to ease deployment and management of BSD firewalls. There's a lot of great open source tools in the BSD operating systems and various add-on components, but they're not necessarily the easiest things to work with or to get to play together nicely. So that's where all the logic in our code makes life easier for people. We recently exceeded 200,000 known live installs from the bogons that we can count. So every system fetches the bogon update once a month, and then we can count how many unique IPs do that. So we've been adding in the neighborhood of 5,000 additional installs per month. We have multiple platforms. The live CD and the memstick are basically the same thing in two different formats. So you can the ISO burn to the live CD and then boot off of that, and actually run off a live CD if you want, but most people run the installer from there to install it to a hard drive. And the memstick is the same, except you can write it to a USB flash drive, which is generally faster and easier to deal with. There are two different versions of the memstick. One has a VGA output, and one has a serial output. So if you have hardware that doesn't actually have a VGA console, or if you just prefer a serial console, that's an option. And the Nano BSD embedded, and that also comes in VGA or serial versions. So 2.1 has quite a few changes. There's a very long list that you can reference if you want to see every little one. But the big one really is IPv6 support. Virtually every single part of the system now has IPv6 support, and that was a major undertaking. It wasn't just a matter of adding that to our code in the front end for the web interface. There are a lot of back-end pieces that either didn't have support, or they weren't quite there, or they had issues, or things along those lines. It took longer than we expected because really the underlying pieces in some ways were not nearly as mature and stable as what we kind of thought or hoped that they would be. We got virtually everything. We have a lot of production networks running IPv6 now. And PBI packages is another nice change. The package system before, one of the issues inherent in it is dependency management. So if you have package A that has a dependency, and then you have package B that has the same dependency, and then you go uninstall package B, you may break package A, or in some cases, if you may even break the base system by having a package uninstall things that it shouldn't be uninstalling. So PBIs are from PCBSD. That's where they originated, and they're entirely self-contained packages. So all of their own dependencies are all built into one app, if you will. It's kind of like the way that macOS apps work, where each app has its own directory that contains all of its bits and pieces. And so then whenever you uninstall any package, it's just uninstalling itself. And if sometimes there are applications that require a certain version of a particular dependency. So any of those you can bundle one version of a dependency with one package and one with another, so that also helps a lot in making sure packages stay stable and can play nicely together. The base OS is now FreeBSD 8.3 from 8.1 in the 2.0x releases. The captive portal is now multi-instance, so where before you could just define a single captive portal and apply it to whichever interfaces you wanted to apply it to. Now you can define as many different individual standalone instances of the captive portal as you want, and then apply that to whichever interfaces that you want. So, for instance, in some businesses, if they have a guest network and an employee network, then they may run a separate portal for each of those. And there are several new uses of gateway groups. That's for multi-WAN failover. So before, you could just use those in your firewall rules to do policy routing, to send traffic to one WAN or another, or load balance it. And then if one of them fails, it would switch over. Now those gateway groups can also be used in other portions of the system to fail over those components. So the dynamic DNS client, you can specify a gateway group there, and then if your preferred WAN fails, then it'll update your dynamic DNS record with the IP of the next preferred WAN. And then it'll switch it back if when the other WAN comes back up. Similar for IPSec, where if the preferred connection goes down, it can automatically switch over to the other one. In some instances, that can be a little difficult or potentially problematic just by the nature of how IPSec negotiates. There's an option under System Advanced where you can flush the security associations, which will drop all of your IPSec tunnels and make them renegotiate. But that's you may need that option depending on the specifics of your multi-WAN IPSec deployment. And VPN also allows the use of gateway groups now. One of the features that most commercial, well, at least enterprise-grade firewalls have is the ability to NAT within IPSec, and that was something that we were missing until 2.1. It's kind of an ugly thing to do, and it's really something that should be avoided if at all possible. But sometimes if you're connecting to a service provider or a partner of some sort, and you have overlapping IP space, there's a good chance that neither one of you is going to renumber your networks. So the only way to actually connect between those is to have NAT within the IPSec. So the Phase 2 entries now have a portion where you can define what the subnet is to translate. So we can just quickly set something up here so I can show you what I mean. Yeah, so here's the local network. The LAN subnet is what was there previously, and then if you need to translate it to something, you can specify what you're going to translate it to below. So if you want it to just be one specific address, sometimes in the service provider scenario, they expect you to translate everything that's coming out of your network to one of your public IPs before it goes across the VPN. So this would translate the LAN subnet to 1.2.3.4 or whatever your public address is, or you can also choose network if you're going to do a one-to-one translation of say an entire subnet. Best to avoid if you can, but there are plenty of instances where you really have no other options. And we rearranged the high availability pieces some. Everything was under CARP settings before, which was a misnomer and probably led to some confusion with users over what things are actually carp and which are pfSync and which are the config sync. So there are actually three distinct portions of the high availability. The carp is the virtual IPs, the ability to fail those over. The pfSync syncs the firewall states between the primary and the secondary systems. And then the config sync syncs the configuration changes that you make from the primary to the secondary. And given it was under carp settings before, a lot of people just came to refer to the whole thing as carp, but that's just one of the three components. So just to make that a little bit more clear, we moved that under high availability. So where it used to be firewall virtual IPs carp settings, we still left the tab there for people who are in the habit of going there, which even includes myself from time to time. But where it actually takes you now is here under system and high availability sync, and that's where you can set up the state synchronization and the config synchronization. Largely the same as before. There are a few additional options on what items that you can sync from your configuration across. And there is a whole list of changes. Quickest way to find the page is just to Google 2.1 site doc.pfsense.org, and that's a pretty lengthy page that has all kinds of more minor things that have changed. So if you're interested in the full list, you can just Google 2.1 site doc.pfsense.org, or if you look in the 2.1 release announcement, the link is in there as well. So just covering IPv6 a little bit and what types of WANs that we support. It's a little bit different than with v4. You can configure it static, which is very similar in that regard to v4. DHCP v6 is an option, and that has prefix delegation. So many of the IPv6, or actually all of the IPv6 dynamic assignment types that are used by providers have prefix delegation. So they're not only, in the v4 world, they just give you one IP. In the v6 world, you get a WAN side IP, but then you also get a prefix delegation within that gives you at least one subnet, at least a /64 generally, but depending on your provider, you may get multiple subnets, /56 maybe, or it varies from one to another, but you get the IP subnets that you can use inside your network, because in the v6 world there is no scarcity of addresses, so NAT and all the ugly things that are inherent in it are a thing of the past for the most part. So your internal, you'll actually have your own public internal subnets that get assigned. So whenever you connect with the DHCP or the PPPoE or 624.6RD, you'll get your WAN side IP and the prefix delegation that will automatically configure your LAN side address subnet. And Slack is the other kind that's stateless auto configuration. So that's generally not something that a firewall itself will use to obtain an IP, but it's an option because in appliance type deployments, that's potentially how you'll want the system to address itself. Some people use pfSense with just a single interface and then run one of the services on there, or one or more, maybe just as a DHCP server. Some people just deploy them as a packet capture tool, or a variety of other things. That's generally not an option you're going to use as a normal firewall deployment, but it is there if you are doing appliance type deployments and need Slack. There are a few things that are missing IPv6 support. Captive portal is a difficult one, just by the nature of how v6 functions. You want to authenticate both the v4 and the v6 at the same time, and machines will generally normally have multiple v6 addresses, and those may shift depending on the OS and how it's configured. So it's not exactly easy to get proper v6 support throughout a captive portal. We hope to see that soon. I'm not sure if that'll make 2.2 or not, but for the time being, if you have Captive Portal enabled, no IPv6 will be able to pass on that interface. Dynamic DNS, it's not really that our code is lacking any ability for v6. There are no providers that offer support for updating Quad A records in DNS yet, so that seems like it's going to be changing in the not too distant future. Whenever it's available from the providers, we'll definitely be able to support that. Though it is probably going to be a little bit different than what you're used to in the v4 world with dynamic DNS, since everything is getting a public IP assigned directly to it. You're actually probably going to want to run your dynamic DNS clients on your internal systems rather than on the firewall. In the v4 world, you're generally using port forwards from the firewall and from your dynamic DNS name and your single public IP to get back to something inside the firewall. With v6, that there's no need for that. There's no ability to port forward with v6 at the moment. So you would just be going straight to the internal machine. So the dynamic DNS clients in v6 will probably eventually end up being run more directly on the client machine rather than the firewall, but we'll have support for those as the providers come along. And the PPPoE and the PPTP servers, those don't have support at the moment due to some missing bits in the underlying components. But hope to have those addressed soon. Everything else is v6 ready. There's maybe some minor things here and there that we can improve upon, but we've got as much v6 functionality as pretty much any commercial firewall out there, and more than a number of them. So a bit on the 2.2 plans. That's what we're working on right now. It's going to be on a FreeBSD 10 base, which brings us a lot of good stuff. The multi-CPU scalable version of PF is in FreeBSD 10, which from some benchmarks that we've seen and some basic initial testing is really nice scalability improvements there. Where right now the most CPU intensive portion of the packet filter is giant lock, so it stays on a single CPU. So what you tend to have on there are other portions like the NIC interrupt loader handlers and the other services that run on the system that will use your other processors, but on a heavily loaded system, what you tend to have is, like, if you have a quad-core CPU, you may have one core that's at 80 or 90%, and the other ones might be at 20 or 25 or something along those lines. And the wireless support, thanks to the work of Adrian Chad, is vastly improved. A lot of people have run into a variety of wireless driver issues, things along those lines, where it maybe doesn't work as reliably as it should. So in 10, that's really changed. A lot of work's been done to improve the wireless driver support in general. And 10 also brings us a number of alternate architecture possibilities. So there are a lot of ARM and MIPS and other non-x86 hardware that is pretty well supported in 10. We don't have any immediate plans. We're more working on getting on FreeBSD 10 first, and then probably evaluate what kind of other architectures would be good to look at. But that's something that may be coming, and that's something that may allow us to get a lower cost hardware platform out there than the x86 kind of things. Probably won't go as far as getting on like a Linksys that you can pick up at Walmart or something, but there are slightly higher end and better quality hardware than that. That's more inexpensive than anything you can buy new today. That may become a possibility. What else that we plan to do? We don't really have a specific list at the moment. A lot of what we do from release to release is kind of dependent on what customers are willing to pay for. The bulk of the development is done by people on our payroll. So if somebody comes along tomorrow and wants some new feature and is willing to fund it immediately, that will more than likely make 2.2. So there'll probably be some other things that that will make it. We just don't know what that will be yet. Release date, we really don't know. That's still to be determined, but we're not looking to make a lot of changes in this release. We want to get on FreeBSD 10 and probably get some various bug fixes and other things as we encounter issues with probably with V6 related things more than anything, and not add a whole lot beyond that because we want to keep the release cycles shorter than what they've historically been. So yeah, my gut feeling at this point is probably somewhere in the neighborhood of 4 months or so from now, probably April, May, maybe at the worst, I would suspect. Okay, moving along to the port forward troubleshooting tutorial. This is an overview of the demo network that I have in place here. This machine that you guys are seeing now is the client machine in question up here in the top left, and it's effectively acting the same as if it were out on the internet. Now, this is actually just interconnected to another laptop that's sitting next to this one that then goes through one pfSense box back to another one back to the actual LAN. But this using the RFC reserved documentation IP subnets. So these are not real public IPs. So let me flip over to that machine. Okay. That one is the router. And give me just 1 minute. Get the other one here. Well, this was working a moment ago. We may get a lesson in routing troubleshooting before we get to port forward troubleshooting. We're allowing everything through to WAN. WAN, yeah, that's fine too. Yeah. Okay, so it should be getting to WAN first, so we'll capture on that host address. Let a couple of pings time out. Okay, so we see it is coming in to the WAN. And then we'll switch it over to the LAN. This is actually very similar to troubleshooting port forwarding, except there's no translation involved. requests. Okay, so they look like they're getting over to the other firewall. And I'll have to get to that one from the other machine. Okay, so the firewall was blocking it actually. So now we should be able to get back to here. Okay. We get the Bogon networks blocking still enabled there. This reserved IP space I'm using to kind of look like public IP space is in the Bogons. I had the entire filter disabled earlier. Okay. And then on the LAN side, see if my web server is actually working still. I just need to fix something on it. Sorry about this. These things normally just work for me, and I've just had no end of difficulties today. I guess it's just one of those days. Okay. And that's behind this machine. Oh, since I had the packet filter disabled, then whenever I connected to the firewall, Chrome established a TCP session. And Chrome is really bad about wanting to hang on to its TCP sessions forever and ever and ever and ever and ever and never wanting to use them again, or never wanting to reestablish a new connection. The problem with any kind of stateful firewall, if you do that, whether it's like resetting the states in the GUI, or if you have the filter turned off and then you turn it back on, it's just going to sit there and try over and over and over again to try to use that same connection that's now dead. If you refresh about 100 times, it may eventually work, but sometimes it's easier just to switch to a different browser until Chrome figures itself out. Most other browsers are not quite so bad about that. If you refresh 3, 4, 5 times or so, they generally will always open a new TCP connection, so you won't have that same issue. But if you do use Chrome, remember if you ever reset the states or anything like that, you may have difficulty with Chrome trying to get back in there. And sometimes if you close the tab and then open it back up, it helps, but a lot of times it makes no difference. The ETA for finish question that just popped up, we might be another maybe 30 minutes or so to to finish the actual presentation, and then I'm glad to take any questions that people have. And sometimes we have another 30 plus minutes of questions. So that how long we'll be here kind of depends on how many questions that we get, but probably be done with the presentation here within half an hour. And I've got my server machine up on the LAN of this host. So that's on 20. Okay, so that is live and working. The source address selection here is something that's been expanded a bit in 2.1, where before you could just pick one of the interfaces. Now there are quite a few more options here. If you have a virtual IP, you can pick that as the source, and these still have the interfaces. And then you can also check with local hosts there. So default just picks the IP that's nearest to the device by the system routing table. So just leaving it as default, it's pinging it from its LAN IP, the 10.0.0.1 address. Okay, and we'll start off. We'll do a. Let me go back to my presentation. So there are basically two different frames that you're looking at in the context of a port forward. You have the one as it comes in from the internet, and that comes into your WAN side. And then you have the one after it's translated that's on the LAN side. So this really simplifies an Ethernet frame to just the things that we care about in the context of what we're talking about today. There's a lot more to it than just source and destination port and a TCP header. But the only things that we actually care about here are the ones that we're showing. UDP is also basically the same in that it has the source and destination ports. So as it comes in from the internet, the source IP will be the original IP of the client out on the internet, wherever they are. The destination IP will be one of your IP addresses on your pfSense. And the source port will be whatever random source port that the source client chooses from the ephemeral port range. That's an important thing to remember. Anytime you're dealing with source ports, that's never going to be the same as the destination port. So that's always a random port. Exactly what range it's chosen from depends on the source operating system. But it'll be somewhere between 1024 and 65535. So the top part of the port forward is the original source and the destination. And we have this big warning here, and we hide this behind an advanced box just because people get it confused a lot and want to set the source port the same as the destination port. But keep in mind that that's pretty much never actually the case. So when you're doing a port forward, the interface is the interface that the traffic is coming in on. So most of the time that's going to be WAN for what you're doing. The protocol is which IP protocol. Most of the things you're going to forward are probably going to be TCP traffic. And then the source and the destination, as they're specified here, are the source and the destination on the packet that's coming in outside. So that gives you a lot more flexibility than what you get in a lot of other solutions where you can, if you have like one specific source IP out on the internet that you want to direct to one particular thing inside your network, you can pick that, and then you can create another using the same port. So a different source IP goes to a different internal destination. So you get a lot of flexibility there. for the most part, you just want to specify any if it's your typical port forward that you want to have accessible from anywhere on the internet. And you usually don't want to specify the source range either. You generally want to leave that to any. And then the destination is the original destination. So WAN address is a common one. If you have additional public IPs, then you can put those in there as well. And the destination port range is the original port on the outside. So we'll just try to forward. Let's say we'll make it 222 externally, and so then everything underneath there is the target things are what is inside the network. So that's what you want it to be translated to down here as it's being passed to the internal network. The source IP doesn't change, and the destination IP gets translated to your what you specify down here. So that host is 10.00.20, and it will just forward SSH to it. So anything coming in on WAN, protocol TCP, any source port, destination to the WAN address, and the destination port 222, then we will translate it to 10.00.20, and the internal port is 22. The no XML RPC sync, if you have a high availability setup, you can check that to prevent it from syncing over to the other side if you only want it on one system for some reason. Net reflection, we have the ability to control that on a per rule basis and various different options. Usually just leave it to the system default. If you need reflection, enable it under system advanced, and it'll be enabled for everything. And that's if you need to access the public IP from inside your network. It'll allow you to loop that through the firewall. Split DNS, generally speaking, is cleaner just because you don't have to unnecessarily loop traffic through your firewall, but that's sometimes not very easy to do. It's if you don't have huge amounts of traffic that you need to loop through, then NAT reflection is just an easier solution. And the filter rule association, just adding an associated filter rule is what you want almost all the time. In PF, there are two portions to traffic translation and whether or not it gets allowed or denied. The port forward, all that does is define where the traffic gets directed. So it tells it any traffic coming in on WAN that's TCP, any source to the WAN address 222, then translate it to this port 22. And after that, it evaluates the firewall rule set. If you don't have a firewall rule that passes it at that point, then you'll see traffic on WAN destined to this 10 IP getting blocked. So the associated filter rule is the way to go pretty much all the time. Okay. And then we have our port forward on the WAN address on 222. And I know this isn't going to work. That's intentional. Probably the best way to initially test a port forward is just trying to use Telnet to connect to the port, because that at least ensures that you can get a TCP three-way handshake on it. And that's just going to time out. So, okay, why does our, and keep in mind the machine that we're on here is effectively an internet host. So if you're trying to test this from inside your network, again, there's a lot more potential complications in doing so. So get on a 3G, 4G card or a wireless hotspot or something like that, and make sure you're testing it from outside the network to start. So if you go to diagnostic states, if the traffic is actually getting passed, you'll be able to see it here. So we don't have a whole lot of traffic going on, so it's relatively easy to see. But if we filter on :222, we see, okay, so this came in, this is the laptop that you're seeing's IP. It shows a source port of 51,001, and it sent the traffic to the WAN IP, port 222, and then that was translated to 10.0020, port 22. The state of closed SYN sent, the SYN sent means the SYN came in from this machine, and the closed on the other side just means nothing replied to it. So why didn't anything reply? Since it's in the state table, we know it's getting to the WAN. So let's packet capture on the LAN side and see what that looks like. And you'll want to filter this. How you filter it, it kind of depends on the situation of your network. I'm just going to filter it by the 20 IP because that host has basically nothing else going on. If you have a host that's sending a whole bunch of internet traffic, you're going to want to filter that down more, maybe putting port 22 in, or if you have some other way to narrow down the traffic. Otherwise, if you end up with a massive packet capture to dig through, it's a lot more difficult to troubleshoot, at least at a glance. Okay, and that's running, so we'll try that again. And it hasn't timed out yet, but that's long enough that it probably got 2-3 attempts in, or a lot more than that, actually. Okay, so yeah, we see that this is the machine that we're on. It sent, it got through. It was sent out to the 20 host on port 22, and nothing came back. Okay, so why didn't anything come back? In this case, I know it's because I don't have a default gateway on that machine. But one way to if we go back to the diagnostics ping screen, we saw that we can ping it if we choose default, which means it's pinging it from the LAN subnet. If we change that to WAN, so it sources it from its WAN IP, since it doesn't have a default gateway, it doesn't know how to reply back to that. So if I add a gateway to that host, as I am doing right now, so pointing it to 10.0.0.1, then it should respond to pings from the WAN. Actually, I may have a firewall on it too. Diagnostics ARP is another place that you can look just to make sure that that host actually shows up and it has the correct MAC address listed there. If it doesn't, there could be an IP conflict going on there. Okay, I just disabled the firewall on there, and now we have we get the response back. So when you tell it into the port, you just get whatever banner that it sends back to you, which in the case of SSH is just a little bit of info about what version of SSH that it's running. And if we add a virtual IP on, let's use .3, let's say. So if we have an additional public IP of .3, you can add it as a virtual IP. You don't want to add it as a type of other virtual IP. Usually I'm doing that to illustrate a point. And we can just duplicate this and Let's put it to 4 twos on that IP. Okay. And let's go to telnet to .32222. Remember that this host that we're testing from is effectively an internet host from the perspective of this network. Don't test it from outside, not inside. Okay, that's sent enough that we should have a state if it would have actually passed the traffic. And you can see we have no port 2222 traffic here. So what happened to that? Let's start with the packet capture on WAN. And we'll filter on that IP there. Set the count to 0 and bump the detail up to full. That won't really matter in this instance. And if you ever need to get the full detail, you can always download the capture and open it up in Wireshark. The level of detail there, it only affects what it shows in the text box. And let's try that again. Okay, and stop that. Okay, and what we get is just an ARP request over and over. ARP request, who has this .3 IP till .1, which .1 is the ISP router in this case. So if that happens over and over and over again, that's because nothing is answering for that .3 IP. That can be because of a missing virtual IP, or in this case, it's because I put in the virtual IP as a type other, which that's only valid if your ISP is routing you a public IP subnet. In this case, the firewall has to answer on that address, so the upstream router of the ISP knows where that is. So we just change that to an IP alias, and /32 mask is fine. And there we go. We're connected there. And we still have that packet capture running, or do we? Yeah. Let's run that again. One of the reasons it's helpful to set the level of detail to full whenever you're looking at something along these lines is because it shows the source and destination MAC addresses. So you can see here's that's the initial SYN connection, and the source MAC is this. That's where it came from. In this case, this will be the ISP router upstream. That would be its MAC address, and the destination MAC address. It should always be the WAN MAC address of your firewall. So if we go to status interfaces, the WAN MAC on this system is that. So okay, yeah, there we go. So yeah, just verify that matches. The reason that's important is because if that does not match, you may very well still see it here. You may see it coming in, but the firewall's not going to do anything with it unless it's destined to a MAC address that it owns. The scenarios where you will see something in there other than your own MAC address or an IP conflict. If something else has that address, your ISP may be sending it to that instead. In which case you'll have to remove that IP from the other device. And maybe more commonly, if you're switching things around, maybe you just replaced a firewall. Maybe you just removed an IP from one firewall and added it to another one. The upstream ARP cache may still have that old MAC address and still be sending that old MAC address. So in that case, if your next hop router upstream is actually local to you, maybe it's a cable modem or DSL modem or some other kind of device that your ISP has on site there. You probably don't have access to it, but if you just unplug it, plug it back in, everything will clear out and it'll be good. In cases where you don't have access, if it does not update, you'll probably need to call your provider and just ask them to clear their ARP cache. The default ARP cache timeout on a Cisco router, for instance, is 4 hours. So you'll have to, and then I've seen some providers up that to even longer. So you may have to wait around a long time if you can't get them to clear the ARP cache for you. Okay, let's change this 222 to go to let's make it 222 internally. Let's just say I accidentally typoed that 22 and made it 222. So now if we go to that WAN IP 222, connection refused. One thing that whenever you're trying telnet, if something kicks back right away with a connection refused, you know that there's a difference between that and when something just times out. If a firewall is blocking something, you will generally just get a timeout, and it will just sit there for quite some time. If you open a port to something that's not actually open, and that host doesn't have a firewall on it, it'll send a reset back, so it'll immediately know, hey, I'm not listening on that, and so you'll quickly get a connection refused. That can, whether it's refused or just times out, can be helpful in troubleshooting things like this. So if we, the only thing it doesn't tell us is who is refusing the connection. Is it coming from the firewall? If you had to reject rule on the firewall, it could do that. That's a possibility, but most of the time it actually comes from the destination host. So we'll start another packet capture. And it's safe to assume that it's probably getting through since we are getting rejected, so we can just start from LAN. You can always start from WAN if you want, but in this case, I know that it's probably going to be fine to do that. And we'll use full detail. And we'll try it again. Okay, immediately refused again. Okay, so the TCP flags are what is of interest here. You'll see the flags S. The TCP handshake, the source host will send a SYN. The destination host will reply back with a SYN ACK, and then the source host will reply back with an ACK, and that establishes the handshake, and then they go on and communicate further from there. If you send a SYN to a port on a host that is not actually listening on that port, if it doesn't have a firewall enabled, it will reply back with a reset to that, which is basically just telling it, I'm not listening on that address. So there's our SYN, and here's response back, and it is coming from that host, and it's going back to our source IP, of course, and flags are, so that's a reset. So that means that tells us that host is not actually listening on that port. So yeah, there is nothing listening on port 222 on that. And let me put it back to 22 internally, it works again. So the things to look at in the packet captures are really these 6 fields on each side that are shown here in this diagram. So the source MAC address on the WAN side generally doesn't mean anything. That's going to be your ISP's router. The times where you want to pay more attention to what that is if you have a more complex routing environment of some sort where you have multiple routers upstream, and sometimes if the traffic's coming in from the wrong router, that can make that can have a variety of complications on the network in general. So in those kind of scenarios, paying attention to the source MAC matters, and you're in the majority of scenarios you just care about the destination MAC on the WAN side, because you want to make sure that that's actually going to your firewall. And then the source IP, you just want to make sure that it matches whatever is defined in your port forward. The destination IP is one of your public IPs. And then from the TCP header, the source port should most always be any, and then the destination port is whatever port that you're using on the outside. So you can verify all of that with packet capture, like I showed there. And then once it goes out the other side, then you can verify the source MAC will always be the LAN MAC, in this case of the pfSense. The destination MAC will be the MAC of the device that's on the internal network. The source IP will stay the same unless you have an outbound NAT config that actually changes the source IP. In most all scenarios, the source IP on the internal will be the same as it was up here. And the destination IP is what the port forward actually rewrites, so it goes from your public IP up here to the private one down here. The source port will also stay the same from what it was externally to what it is internally, unless you have manual outbound NAT set up and are actually telling it to rewrite source ports going out of LAN. And then the destination port is whatever that target port is that you specified in the port forward rule. And let's go back here and if you go to firewall rules, I have allow all rules in here just so I can get around in the test network here. But if you have let's change this to the WAN address. So that way I'll still be able to get in and manage it. And we can delete that. And let's disable both of these firewall rules. These are the ones that are linked to that port forward. Now, if we try to get back there, it's not going to be able to connect. Okay, it timed out. So if we look at our firewall logs, there's that traffic right there. On WAN, this is the IP of this laptop that we're on, and then the destination is the internal address. Remember, the port forward applies to translate the ultimate destination of the traffic, and then it's evaluated by the firewall rule set. So because when it hits the firewall rule set, that destination IP is 10.00.20, then whenever the firewall rules get evaluated, they'll actually only evaluate to destination IPs of 10.00.20. So even though the original address of that traffic was the WAN address, it doesn't get evaluated by the firewall rules until after it's translated. So since we don't have these rules here are disabled to allow that traffic, then it's getting blocked. And once we enable that rule, it allows it again. And that really covers port forward troubleshooting. There's a page on doc.pfSense.org that really outlines all the common causes of various issues that people run into. So 14 various ones here. We went through the most common things, but the packet capture is really the big deal. Capture WAN side first. If you don't see it WAN side, and you don't see something like the ARP requests over and over and over again whenever I had that type other virtual IP in there, so that there was nothing answering on that address, so that's why it wasn't getting to you. If you don't have like a repeating ARP request and you don't see any traffic coming in to that address, then something upstream of it is blocking it. If you do see it on WAN, then you can continue troubleshooting further, looking at the state table like we saw to see if it was getting passed. Check the firewall log, and if you have a state entry there and nothing's getting blocked on the firewall log, then switch your packet capture to the LAN or whichever internal interface that your ultimate destination host is on, and capture there and see what it looks like. And if you need to go a step further, then capturing on the actual target host can be helpful as well. Make sure the traffic's actually getting to it, and is it replying to it. Especially pay attention to, if it is replying to it, what what MAC address the host is actually sending it to. So if it's got a wrong default gateway, or if it's got something weird in its local routing table on the host, it may be sending it back to the wrong device. You want to make sure that if it is replying, it's sending it back to pfSense so it can send it back out to the internet. Okay, thanks for joining us. Like I said, the first Friday of every month here on out, we'll have something kind of along the same lines as this, where we'll pick a topic and we'll go through and show you how to do certain things or troubleshoot certain things, and the recordings will be available for subscribers. So that it's important to keep the development of the project going. There are a number of great volunteers in the community who help us out, but ultimately the bulk of the development work is done by people on our payroll. So that's it's critical to the growth of the project that folks can help us out there as much as they can. So thanks for being here. I will take any questions that you guys have if I can figure out where you guys can even type questions. The group chat, I guess. Turn off my screen share. Having that thing on over and over again is kind of makes me dizzy. Okay, well, I guess we don't have any questions today, or else I'm just not seeing them. All right, well, thanks for coming, everybody. And the recording of this will be up on YouTube. This one will be publicly available for everyone. So we'll put the link out to that later today in our Google Plus group, our Facebook group, Twitter, all that good stuff. So thanks, and we'll hopefully see you next month.